Welcome back to NEET online classes. In this session, we will discuss volume expansion of gases. Students, already we know that gas has only the volume expansion. I mean, gas has only definite volume but not having definite size and shape. Now, let us see what is the volume expansion of gases at different conditions. We know that gases can be heated under two conditions. One is under at constant pressure, second one is at under constant volume. Because gas has due to more compressibility, the gas cannot be heated under the same two conditions. I mean, if you are taking some amount of heat to the gases, definitely the volume and pressure both are changes. Already we have learnt about the effect of pressure, radiating pressure, right? So let us see the both conditions, the conditions of under at constant pressure and under at constant volume. So let's see, the concept is coefficient of volume expansion. Before that, students, already we know when heat is provided to the gas, definitely its volume will changes. Change in volume directly proportional to original volume, directly proportional to change in temperature, or the change in volume is equal to some constant we are calling gamma. There we are defined coefficient of volume expansion. See here, our concept is coefficient of volume expansion of the gases. See here, now I will take the gas in a container. See here, this is nothing but the gas I will take. I will take a vessel. Inside the vessel I will take the gas, either real gas or ideal gas I can take, no matter. See here, this is nothing but the vessel. In the vessel I will take the gas. This is nothing but the gas. This is the gas provided. Look at me here. This is some amount of gas in the container, right? I said that gas can be heated under two conditions. One is under constant volume, second one is at under constant pressure. See here, when some amount of heat is given to this gas, let us take some amount of heat is given, right? Consider initial volume of the gas is available. What is the initial volume? V1 is the initial volume or V0 is the initial volume at what temperature? At temperature 0 degrees Celsius, right? Then after heating, volume of the gas may be expanded. Consider V is the volume of the gas at what temperature? At temperature T. At temperature T. According to volume expansion, what you are calling? Change in volume directly proportional to original volume, directly proportional to change in temperature. Shall I take here? According to volume expansion. According to volume expansion, change in volume directly proportional to original volume, directly proportional to original volume, and directly proportional to change in temperature, or the change in volume V minus V0 equal to some constant alpha at what value? Alpha at a constant pressure now. See here, at constant, or you can call directly alpha into how much? V0 into delta T. What is alpha here? Alpha represent here volume coefficient of expansion of the gas. See here, how to represent volume coefficient of expansion? Volume coefficient of expansion, gamma is equal to, alpha is equal to which? Alpha is equal to V minus V0 divided by V0. What is delta T? Final temperature minus initial temperature, right? See here, what is V minus V0? V minus V0 represent change in volume due to heating. What is V0? Initial volume at 0 degrees Celsius. That T minus T0 represent change in temperature. From this, how to write? From this, alpha can be written, alpha is equal to how much? V minus V0 divided by V0 into how much? Delta T, right? Or you can write this value, what we are calling? Volume coefficient of expansion of the gas. Initially, how to define volume coefficient of expansion? Volume coefficient of expansion is change in volume to original volume per degree rise in temperature. Per degree rise in temperature. See here, this equation how to write? This equation V minus V naught equal to alpha, or from this V is equal to how much? V is equal to V naught into bracket how much? 1 plus alpha into T. From this equation you can write, right? But students, this volume coefficient of the gas alpha has two values. It has two values. Initially, temperature is 0 degrees Celsius. At 0 degrees Celsius, how to write? Alpha is equal to V minus V naught divided by V naught into T. It is one value. Shall I write separately here? Shall I go for separate values? Look at me. For separate values, see here, alpha can be written like this. For initial value at 0 degrees Celsius and T degrees Celsius, volume coefficient of the gas can be represented. Volume coefficient of the gas. Shall I represent here volume coefficient of the gas? Alpha is equal to V minus V naught whole divided by V naught into how much? T. It is one value of coefficient of expansion of the gas at 0 degrees Celsius and at T degrees Celsius. Right. Now let us take now volume of the gas. Volume of the gas is V1 at what temperature? Temperature is T1 degrees Celsius. Right. Now volume of the gas is V2 at what temperature? At temperature T degrees, not T2 degrees Celsius I can take. Right. You know this equation. For this how to write? For this value V is equal to how much? V is equal to V naught into bracket 1 plus how much? Alpha into T. Right. According to this relation. But at this volume V1 at T1 temperature, at V2 volume at T2 temperature, how to write? Shall I take here directly? For V1 volume T1 temperature, this value can be written. How to write? V1 is equal to how much? V naught into bracket how much? 1 plus alpha into T1. Right or wrong? Now I am calling this is equation number 1. What about this? Equation number 2 shall I call? Now at volume V2 and temperature T2, shall I take here? V2 is equal to how much? V naught keep it up same into bracket 1 plus alpha into T2. What about this? Equation number 3, right? Very simple. Divide equation 2 by 3, you will get the values. Alpha at a different temperature at T1 and at T2. Right. Shall I take here? For V1 divided by V2, I will take V1 divided by V2 is equal to how much? V naught into bracket 1 plus alpha into T1 divided by how much? See here, T1. This is how much? V naught into bracket 1 plus alpha into T2. Right. This value get cancelled. Just cross multiplied. What values are getting? See here. V1 plus V1 alpha into T2 minus or equal to V2 plus V2 alpha into how much? T1. Right or wrong? I need V2 minus V1. V2 minus V1, how to write from this? See here. V2 minus V1 is equal to how much? V1 alpha into T2 minus V2 alpha into T1. Right or wrong? Here alpha is common. If alpha is common, mean how to write? V2 minus V1 is equal to V1 into T2 minus V2 into T1 into bracket how much? Alpha. Then alpha value, volume coefficient of the gas. How to write volume coefficient of the gas? Volume coefficient of the gas is V2 minus V1 divided by V1 into T2 minus V2 into T1. This is volume coefficient of the gas. At what temperature? At the temperature T1 and at the temperature T2. Right. But at the temperature 0 degrees Celsius and at the temperature T degrees Celsius, what is volume coefficient of the gas? Volume coefficient of the gas can be represented by this equation. I mean, at 0 degrees Celsius, at a 0 degree Celsius and at T degree Celsius temperature, volume coefficient of the gas can be represented by equation number 1, and for equation number 4 represent volume coefficient of the gas at the temperature T1 and at the temperature T2. Right. This is what? Volume coefficient of the gas. But already I said that gas can be heated under two conditions, under constant volume and under constant pressure. This is what? When the gas is heated under constant pressure, all these are conditions valid, only at the pressure of the gas remains same and only volume changes. Now let us take the reverse situation. Reverse situation means now I am heating the gas by keeping volume as constant and pressure going to be changes. Shall I take the condition? Let us go for the condition. Okay students, let us move. Now concept is pressure coefficient of the gas. ಇವಾಗ ಏನು ಮಾಡೋಣ, ಗ್ಯಾಸನ್ನ ವ್ಯಾಲ್ಯೂಮನ್ನ ಕಾನ್ಸ್ಟೆಂಟ್ ಇಟ್ಟು ಪ್ರೆಷರನ್ನು ಚೇಂಜ್ ಮಾಡೋಣ. ಶಾಲ್ ಐ ಟೇಕ್ ದ ಸಿಚುವೇಶನ್ ಹಿಯರ್? Now I will take again same gas. I will take the ideal gas in a container. Look at me. Shall I take the ideal gas? I am taking, this is nothing but ideal gas. Perfect gas I am taking. Like this. In a container I am taking. Right? Some amount of gas is provided. Let us take, this is nothing but some amount of the gas. Right? Consider now gas is P0 pressure at a 0 degree Celsius. See here. Shall I take here? Now pressure of the gas is how much? P0. At what temperature? At a 0 degree Celsius. Right. Now let us consider this gas is heated. Gas is heated under what condition? Under volume as constant. Now when gas is heated, the pressure P0 changes to P at what temperature? At a temperature 0 degree Celsius. Right. Again let us go. The change in pressure directly proportional to original pressure, directly proportional to change in temperature. Shall I observe here? Look at me. The change in pressure I am taking. Change in pressure means final pressure minus initial pressure directly proportional to original pressure, directly proportional to change in temperature. Right? Now change in pressure can be written. Change in pressure P minus P0 equal to again some constant beta I am calling. Beta into P0 into delta T how much? T minus 0, final temperature minus initial temperature. Right? Then again from this, what is beta? Beta represent pressure coefficient of the gas, can be written P minus P0 divided by P0 into how much? T. This is what value? Pressure coefficient of the gas. Again the pressure coefficient of the gas, how to define? P minus P0 represent change in pressure, right? P0 represent original pressure, T represent change in temperature. This is what? This is when the pressure of the gas at 0 degree Celsius and pressure of the gas at T degree Celsius. Right. Now pressure coefficient of the gas is the ratio of a change in pressure to original pressure per unit degree rise in temperature. Per unit degree rise in temperature. Or again from this, how to write P value? What is P value here? P can be written. P is equal to how much? P0 into bracket 1 plus beta. Beta into how much? T value. This is nothing but the pressure, final pressure at a T temperature degree Celsius. Right. But this pressure coefficient of the gas, again it has two values. The pressure coefficient of the gas at 0 degrees Celsius and at T degrees Celsius can be represented by this equation. Shall I call this? This is equation number 1. Right. What about this? This is equation number 2. Now, same gas I am going to heat at T1 degree Celsius temperature and T2 degree Celsius temperature. Shall I take the condition? I will take again same gas. Look at me. Same amount of gas I am taking in a container. This is the container. In the container I am taking the perfect gas. Perfect gas I am taking. Right. Consider it is perfect or ideal gas I can take. Like this. Now, pressure of the gas is P1 at a temperature T1 degree Celsius. Shall I take here? Now, the pressure of the gas is what? At a P1 atmosphere at a T1 degree Celsius. Are you following me? When it is heated. Look at me. This pressure is heated. This gas is heated. This gas is heated under what condition? Gas is heated under constant volume now. Now, after some time the pressure also changes. The pressure changes, P1 changes to P2 at what temperature? At a T2 degree Celsius. Right? Now again let us go for change in pressure. Change in pressure means final pressure minus initial pressure. The change in pressure P2 minus P1 directly proportional to original pressure, directly proportional to change in temperature. Right? Again shall I take? Look at here. Or directly you can write no matter from this. See here. P2 minus P1. Or can take like this also, no matter. At initially the pressure of the gas is P0. According to this relation I can write directly. See here. Initially what pressure is there? P0 pressure is there. P0 pressure at a 0 degree Celsius. 0 degree Celsius initial pressure. When temperature is T1. When temperature T1. Initial pressure is P0. According to this relation how to write? See here. For P1 pressure T1 degree Celsius. According to this relation how to write? According to this relation, P can be replaced by P1 and P0 into bracket 1 plus beta into T1 value. Right? Now, again let us go. At the P2 pressure, T2 degree Celsius temperature. P2 pressure, T2 degree Celsius temperature. This equation can be replaced. How to replace this equation? Just P can be replaced by P2 and P0 into bracket 1 plus gamma into T2. Right now, just divide these two equations, P1 divided by P2, you will get the coefficient of pressure expansion at a different temperature T1 and T2 degree Celsius. Shall I go here? P1 divided by P2. P1 divided by P2 is equal to how much? P0 get cancelled. What is remaining? 1 plus beta into T1 whole divided by, sorry, it is beta not gamma, this is beta, 1 plus again beta into how much? This is T2, right? Just cross multiplication mean P1 plus beta into T2, again this much, how much? P2 plus P2 into beta into how much? T1. Right or wrong? See here. Cross multiply P1 here. Here P1 will come. P1. Right. Again let us go. The final pressure minus initial pressure shall I take? Final pressure minus initial pressure. Look at me. Final pressure minus initial pressure. See here, from this how to write? P2 minus P1 I am taking, P2 minus P1. See here, P2 minus P1 is equal to how much? P1 beta into T2. P1 beta into T2 minus how much? P2 beta into T1. Beta into T1. Here common is beta. Then how to write? See here. P2 minus P1 is equal to how much? P1 into T2 minus P2 into T1 into bracket how much? Beta value. Great. Then pressure coefficient of the gas at temperature T1 and T2, how to write? This is P2 minus P1 whole divided by P1 into T2 minus P2 into T1. This is what? Pressure coefficient of the gas at T1 degree Celsius and T2 degree Celsius. Now, actually at 0 degree Celsius and T degree Celsius temperature, what is coefficient of pressure? Coefficient of pressure beta is equal to how much? It is P minus P naught divided by how much? P minus P naught divided by P naught into T. It are two values. Right? Pressure coefficient of the gas and volume coefficient of the gas as a two values at 0 degree Celsius and at T1 degree Celsius and T2 degree Celsius. But students, there is a few relation between pressure coefficient of the gas and volume coefficient of the gas. There is relations are available. Shall I take here? Now next I am taking relation between alpha and beta. Relation between volume and pressure coefficient of the gas. It is very important. How to obtain here? Look at me. The relation between pressure coefficient of the gas and volume coefficient of the gas. I am saying in it now, pressure coefficient of the gas and volume coefficient of the gas both are equal. Pressure coefficient of the gas or volume coefficient of the gas must be equal to 1 divided by 273 times of increase in volume per degree Celsius. I mean per degree Celsius the pressure or the volume changes by the amount. Original value divided by 273 point times per degree rise in temperature. See here, directly I am going relation between volume and pressure coefficient of the gas. Look at my students. We know that when the gas is heated under constant pressure at 0 degree Celsius and at T degree Celsius temperature. See here, how to write? The volume expansion V is equal to how much? V naught into bracket 1 plus alpha into T. Shall I call this in the equation number 1? What this is? Volume coefficient of the gas at 0 degree Celsius and at T degree Celsius. Right. Equation number 1. Similarly, the pressure coefficient of the gas at 0 degree Celsius and at T degree Celsius. Shall I take here? P is equal to what, right? P is equal to P naught into bracket how much? 1 plus beta into T. 1 plus beta into T. Shall I call this equation number 1? What I need? I need only pressure coefficient of the gas and volume coefficient of the gas. See here. Just equate these two values 1 plus alpha T and 1 plus beta into T. If you compare these two, you will get what is the comparison between pressure coefficient and volume coefficient of the gas. Look at me students. How this is? Just compare, just equate these two values. Leave this V is equal to V naught and P is equal to P naught on both sides. Look at me here. What to do? You are equating these two values. How to equate? 1 plus alpha into T equal to 1 plus how much? Beta into T. Or again from this how to write? Alpha into T equal to how much? Beta into T. Again T get cancel. What you are getting? Alpha is equal to how much? Beta. I mean the pressure coefficient of the gas and volume coefficient of the gas has the same meaning. If we heat the gas under constant volume and if we heat the gas under constant pressure, the both ratio must be equal. I mean pressure coefficient of the gas and volume coefficient of the gas are lying in the same ratio. And how they changes? Actually V naught is the initial value. How they changes? Alpha or beta changes 1 divided by 273 times of original value per degree change in temperature. I mean per 1 degree Celsius. Volume is expanded by 1 divided by 273 times of original value. So these are what? Concerned to volume expansion of the gas. In the last class, what we have dealt? We have dealt about the volume expansion of the liquid. So let us start the few numericals concerned to this pressure, this expansion of liquid and expansion of gases. Students, already in the last class we have learned that apparent expansion of the gases, apparent expansion of the liquid, real expansion of the liquid, right? The relation between real expansion, real coefficient of expansion and apparent coefficient of expansion already we have seen. Now let us take the few numericals on it. Shall I take? I will go for numerical number 1 first. Say here. On both we will see expansion of liquid and expansion of gas. Both numericals we will see in detail. Okay. Now directly we will for the numerical. Students, we will continue the numericals on thermal expansion of liquid and gases in the next class. Thank you.